All right, hey there, guys. We're going to work with binomial theorem today. It's from Pascal's triangle. It looks like this, and then we're going to find out how this is useful and why this guy named Pascal did any of this stuff. Okay, so basically what we're going to do is work with some binomials today. And first thing, anything to the 0 power is 1, so that's not too bad. If I take the whole thing to the first power, I just get x plus y. Right? If I do this, remember that means I have to FOIL it. So x plus y, x plus y. All right, so we're going to get that x squared. We're going to get an xy and another xy. So I'm going to make it 2xy and then plus y squared. Now, if I take that answer and I multiply by another one, all right, so I get x plus y. So you can see how this is developing to something a little bit larger. I'll give you this one. We get x cubed plus 3x squared y plus 3xy squared and plus a y cubed. Okay, now it's not necessary, but at this point I want to start writing in these other coefficients, and you're going to see why as we look at that triangle down below. All right, so what we're going to do is start to make some of that correlation. So we're up to that third one. So here's the one we just did, and this is the reason why I put those coefficients in there. Notice we had 1, 3, 3, 1, and I have 1, 3, 3, 1. So this is where we're going to start making that transition and notice a few things. So 1, 4, 6, 4, 1. Okay, so this is what we're going to fill in is 1, 4, 6, 4, and a 1. The other thing we want to start to take notice here is I had x cubed, right, because it was x to the third power, and x squared, x to the first, and then no x's at all. With my y's, I had no y's. Then I went to the first power, second power, third power. So we're just going to continually count up and down. So I'm going to start with x to the fourth plus x to the third. Since that's to the third, I'm going to bring in y to the first power plus 6, x to the second, y to the second, plus x and y to the third, and plus y to the fourth. So the thing I want to happen is I want my exponents to always equal 4 because I'm dealing with the fourth power for this binomial expansion. All right, so having said that, let's take a look at the fifth row here. So 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. This is, everything's positive, so I don't have to deal with that. So I have x to the fifth because I don't have any y's at all. So this is 4, 3, 2, 1, and then no y's at all. So that's one strategy. And then we're going to go with y1, y2, y3, y to the fourth, and y to the fifth. So that would be our answer if we did x plus y times itself 5 times. So here's some things that we have. We have n plus 1 terms, right? So if I had the fifth power, I have 6 terms. Okay. The first one is always going to start with x to that power, right? X to the fifth. And the last one is y to that power. All right. Our terms decrease x by 1, and the exponent for y increases by 1. So that's what we eventually got to for the last one. So 5, 4, 3, 2, 1. And then we went with y to the 0 power, so it's not present. Y to the first, second, third, fourth, fifth. Okay, so we kind of got all those ideas. The degree of each term is n. Okay, so that means, remember, this is what I highlighted up here. I wanted all these to be equal to 4. So 3 and 1, 2 and 2, 1 and 3. So we get 4. And we want the coefficients to be symmetric. Okay, so first and last, second and next to last. All right, so whether we have that or not, that's going to work. All right, so how do we build this triangle? So if I don't give you this triangle, which I don't plan on giving this to you all the time, right? So we're going to start with 1, then we go 1, 1, and then 1, 2, 1. So what's happening is we're making kind of a, as you can see here, we're adding these two to get that one and adding these two to get that one. And so if I take, I always start with 1. So I add these, and I add these. All right, so I'm going to get 1. I'm going to get 4. I'm going to get 6. I'm going to get 4. Okay, so there's no secret to it. This is what Pascal did. He found all this information. Well, he noticed a pattern, I should say. He didn't find the information. There's nothing to be discovered here. So we can continue to work with those. So I might scroll up and down and give you those as we get started here. So here we have example. This is going to be to the fourth power. So I'm going to go ahead and write this in 1, 4, 6, 4, 1, right? Because we're definitely going to use that. Now I took out the y and put in a number, and we'll see how that works as we work through it here. So the next thing we're going to do is, so these are my coefficients. I want x to the fourth, x to the third, x to the second, x to the first, and no x's. All right, and the last thing we'll have to plug in here is we don't have any 3's at all. Now I want 3 to the first power. Then I want 3 squared. Then I want 3 cubed. And then I want 3 to the fourth power. So we start to get some of these. So now that I have another number in play here, we're actually going to multiply those. So you get 1x to the fourth. Remember, we can leave off the 1. If you like to see how it's symmetric, we can write it in. So 3 times 4 is now, so it's 12x to the third. All right, this would be 9 times 6. So we're up to 54x squared. We got 27 times 4. So I think that's 108x. And then plus 81 gives us our answer. A little bit nicer, right? So the only thing I'd have to do, well, my options are I can multiply x plus 3 times itself 4 times. That seems like it would take a while. Or if I didn't have the triangle, right, I would just go ahead and write my triangle out until I get to the fourth one. Unless I'm pretty good at memorizing, then I've memorized though. All right, so if I have the third power, remember that's 1, 3, 3, 1. Right, you kind of know you're on the right level, right? Some things that you'll also notice is if this is the fifth power, right, that second number should always be that. So that's kind of the quick way. If I don't give you this first column, right, you don't really need it. You're just going to follow that second term coefficient, and that'll get you where you need to be. All right, so let's try this again. X to the third, x squared, this would be x and then no x's. And this time we're going to bump up the other one. So no 5s, 5 to the first, 5 to the second, and 5 to the third. You could do some parentheses here if you want to. And so far everything's been positive, so that makes that a little bit easier. Again, we had French mathematician areas on the side. I'll move that over as soon as we get this answer. We can check that out. So we got x to the third, we got 15x squared. This would be 25, so 75x, and this would be 125. So that's kind of the gist of the whole thing. Like if you get what we're doing, then you're probably in good shape for the rest of it. All right, so this is all thanks to Pascal. Found this one. He had a pretty neat quote here. I've made this letter longer than usual, only because I didn't have time to make it shorter. And that's what he did for us, right? It's kind of full circle of the whole idea is we're trying to make this whole process shorter so that you don't have to write this stuff out. So we thank you, Pascal, and you rest in peace. All right, let's see if we can get this thing to scroll a little bit more. All right, what if we add some extra numbers and all sorts of stuff in here? Does it change anything? No. Or as I like to say, nah, doesn't change anything. Okay, so first of all, we just did a 3. Do you remember what it was? 1, 3, 3, 1. Okay, so that means I need 3x to the third, I need 3x squared, and then I need 3x to the first, right? So I'm going to leave that off because we're going to have a lot of stuff going on here. We're going to switch this out. So I don't have a -2, so that's okay. Now I have -2 to the first power, and I have -2 squared, and I have -2 cubed. All right, so notice what I did this time is I'm starting, since I have negatives, I have extra variables, I'm going to put everything in their own set of parentheses. That way this works out a little bit nicer. So we know it's 27x cubed. All right, we got -2 times 3 is -6. So I'm just going to make this -6. Nope, can't do that yet, right? I almost forgot in here. So let me clean up each and every part of this before I do anything else. So this would be 9x squared. We got times 3 from the coefficient and then times -2. So what are we up to, guys? 27 doubled 54. All right, so -54x squared. All right. The next term looks like we're going to go positive, right? Because I got 4 here, I got 3x there, and another 3. So 27 times 4, that's our 108x. And on the end, we just need negative, negative, negative. So it'd be -8. So we're in good shape here as well. All right, so let's just get this one set up. At this point, I hope that we're okay getting everything else together. All right, remember what line 4 was? Yeah, was 1, 4, 6, 4, 1. Okay, so I don't even know if I gave enough space in here. I'm gonna have to write a little bit smaller, so I have to zoom in. That's okay. Let me do that. So I need 2x to the 4th, 2x to the 3rd, 2x squared, and a 2x. All right, and then we'll go back to my orange here. So we don't have any y's, so that one's done. This is going to be 3y to the 1st. This is going to be 3y squared. This is going to be 3y cubed. And this will be 3y to the 4th. All right, so as we work through all of our order of operations, we'll get a final answer here. Okay, but I don't want to speed things up too far, but once we see it set up, after that, it's all computation. And we can post some answers as you need to hear for class. All right, what do we got next? All right, so we're gonna go back. So now what you noticed is we can throw in this negative stuff. So we had a little bit of that with just the numbers. So how's it look with the variables? Remember for 5, our 5th row, 1, 5, 10, 10, 5, 1, 1, 2, 3, 4, 5, 6. Why am I counting it? I want to make sure I'm on the right row, right? I know I had 5 as the second coefficient, so we're probably in good shape. All right, next thing we have, I'm going to go through the a's, a to the 5th, a to the 4th, a to the 3rd, a squared, a, no a. All right, so no b's. Now I have negative b to the 1st, negative b to the 2nd, negative b to the 3rd, negative b to the 4th, and negative b to the 5th. Okay, so I'm going to put plus signs in here just temporarily until we figure out what's going to happen with those. All right, so this one really just plays on all the signs, but the coefficients are going to remain what they are. So we don't have to do too much more with that. Okay, so a to the 5th. So notice this negative is going to make it -5. A to the 4th b. This is going to go back to positive, so it's going to say a positive 10. This is going to go negative. So we're going to change every other sign to get that final answer. Okay, so pause that for a minute and go ahead and jot in your final answer so we can check those out. All right, so 4th, remember row 4, so it has to be 1 and then a 4. So what was in between there? 6, 4, and 1. All right, so same idea here. C to the 4th, C to the 3rd, C squared, C and no C's. All right, then we'll go grab D, no D's. So negative D squared, negative D cubed, and negative D to the 4th. Okay, notice I'm intentionally putting that power on the outside. Other things you want to make sure we have is the exponents always add up to 4 as we go through all of these. All right, so again, this one only has to deal with the signs. All right, I left you hanging on the other one. So here, I'll write this one in. So minus 4c cubed d. This one goes squared, so it's plus 6c squared d squared. And this will be negative 4cd cubed. And then this will become positive d to the 4th. So we're in good shape. All right, not trying to rush the day away here. Just trying to get these set up and help you through any struggles that you may have. All right, so we got a couple left here. If you've got it down, then go for it. Some things we want to remember: 4, so it's 1, 4, 6, 4, 1, and then trying to squeeze other things in here: x to the 4th, x cubed, x squared, x, and then negative 2. Oh, I don't need one there, right? Because that would be the 0. Negative 2 to the 1st, negative 2 squared, negative 2 cubed, negative 2 to the 4th. So I go plug plus signs in here just temporarily. And again, so we'd work through all those. Again, just watching the signs. Now, if I put W's and J's here as I look to the right, okay, same thing. This problem just gets very, very large. So we'll get it set up. I'll give you a final answer that way you can double check that you're doing okay. But coefficients, 1 has to be a 5. Remember, it then goes to 10, 10, 5, 1. All right, how do I know that? Yeah, you can write the whole table or triangle out, or I can just double check with one that I have written nearby here. 2w to the fifth, 2w to the fourth, 2w to the third, 2w to the second, 2w to the first. All right, and then see if I can write small enough to squeeze these in here. This one needs no j's. This one needs negative 5j to the first, negative 5j to the second, negative 5j to the third, negative 5j. I'm going to have to move this one over. Negative 5j to the fourth, negative 5j to the fifth, and I get my 1 back in here. Okay, so temporarily I'm going to put those all back in as plus signs until we work through it. So what's our final answer look like? All right, so let me get this one jotted down here. Try and write it nice and clear for you. 32w to the fifth. That pen is awful. I'm never going to make it through with that. Here we go. And then we have minus, right? Because we get this negative, we get this whole thing going on. So minus 400w to the fourth j plus 2000 w third j squared minus 5000 w squared j cubed plus 6250 wj to the fourth, one more term, minus 3125 j to the fifth. All right, so it's all in the setup and what we have going on there. All right, that's kind of the brunt of it. If you need a break, take a break. We got one more idea to talk about here. All right, welcome back. Or if you didn't go anywhere, that's fine. So third term. So this time, I don't want you to do the whole thing. We're just saying, all right, what's the third term in this whole thing? So we're really trying to think about the process of what we're doing. So row 5, 1, 5, 10, right? I'm stopping at the third term. This is the only thing I really care about. Remember, this would be 3x to the fifth, 3x to the fourth, 3x to the third. And this would be negative 1 to the 0, negative 1 to the first. So this is negative 1 squared. So I'll kind of stack them here. Maybe that's something I could do all the time and then get an answer. So either way it works. So we got 3 cubed. So I got 10. I got 27x cubed, and I got 1. Okay, so we know this should be 270x cubed for that third term of what we're after. Okay, what about the fifth term we're working with? Hey, we got it right. Okay, the fifth term, so x to the fourth power this time. So let's figure out where we're at. So we're dealing with 1, 4, 6, 4, and 1, 2, 3, 4. Okay, so this is the one that I'm after. Okay, so this is a to the fourth, third, second. This is a to the first power. And if that's the first power, then I have to have, that's not negative. I need 5b must be to the third power, because these powers have to add up to that 4. 5b squared. There we go. So again, I'll list each one separately here as a grand total. This is 5 times 5, 125. This would be b to the sixth. Okay, so if I have 4 of those, that's 100. It's 500. ab to the sixth. Okay, they had 625, so that's not good. 125. All right. Oh. Oh, yeah. 625. All right. Well, that works. Well, if I can multiply, that'd be all right. Okay. Oh, the fifth term. What am I doing? 1, 2, 3, 4. I did the fourth term. All right. Well, that's how you would do the fourth term, just so you know. All right. So the fifth term goes back to 1. That means I have a to the 0. I have 5b squared, and that should be to the fourth power. So that's your 625. That's your 1. That's your 1. That's your 625. And this is going to give me b to the eighth. All right. So good thing I had that on there. I would have never noticed I was doing the wrong term. Hey, sorry about that. It was either a mistake or I was just adding an extra problem on there. You count it either way you want. All right. So if you're with me in class, right? These are the things we're going to work on for homework. So if you have this down, otherwise you might want to take a break because that took a while. So good job hanging in there. If I would have made it shorter, I could have.